Hello everyone, and thank you for joining us today for the Garmin Connect Developer Program, an inside look at API integrations breakout session. My name is Ben Prihoda, and I am the technical lead on the Fit SDK team here at Garmin. Over the years, I have worked on many projects both inside and outside of Garmin using the Developer Program APIs. And today, I would like to share with you some of what I have learned along the way. For today's presentation, we're going to be covering the basics of getting started with the Developer Program APIs, as well as covering a few intermediate and advanced topics. So hopefully there will be some takeaways regardless of your level of experience working with the APIs or any other APIs. We're going to start out with a high-level overview of the Garmin Connect Developer Programs. Next, we'll talk about how to request access to the APIs and what to expect during the application process. Then we'll dive into getting started with the APIs and some best practices. After that, we'll look at a few of the APIs in a little more detail, and at the end of the session, we'll have time for Q&A. You can type in your questions in the chat box at any time during the presentation, and we'll answer as many of your questions in the time available at the end of the presentation. There are multiple developer programs here at Garmin. Each program has its own distinct purpose, but what you'll find is in many cases is that the different programs complement each other. For instance, ConnectIQ, which allows you to develop watch faces, data fields, widgets, and apps that run on Garmin devices. Ant Wireless Networks enables wireless connections between sensors and devices. The Fit SDK is the industry standard for sharing activity data between devices and applications. And last but not least is the namesake Garmin Connect Developer Program, which is a set of REST APIs for interacting with Garmin Connect. You can find information on each of these programs at developer.garmin.com. The focus for today's breakout session will be on the Garmin Connect Developer Program APIs and how to get started using them in your applications. The Garmin Connect Developer Program is made up of 5 different APIs. The functionality is grouped into these 5 APIs to reduce the overhead for developers that are only interested in certain features, and to give users a fine-grained level of control over what data your application has access to. The Health, Activity, and Women's Health APIs allows your platform to receive health and activity data from a user's Garmin Connect account. This includes data recorded by a Garmin device, uploaded to Garmin Connect by partner apps, and data that the user enters manually. The next 2 APIs are the Training and Courses APIs, which allow you to send workouts, training plans, and courses from your application to a user's Garmin Connect account. Once loaded into a user's Garmin Connect account, workouts, training plans, and courses will then be automatically synced to a user's compatible Garmin device. All 5 APIs use OAuth 1A for authorization, and something new in the last year or so is that all 5 APIs are accessible using a single OAuth consumer key and secret. If you've been using Garmin's APIs for a while, then you know that this has not always been the case. The new single consumer key makes integrating with Garmin's APIs easier, and more importantly, makes things a lot less confusing for end users. Prior to the API sharing a single consumer key and authorization, end users had to authorize each API individually. This was not an ideal experience for the end user, and the single consumer key aims to solve this. We'll talk more about authorization later in the presentation. That was a very quick run-through of the APIs that Garmin provides, so now let's talk about what you need in order to work with these APIs. For starters, most of the Garmin Developer Program APIs are event-driven. When new data is available, the Garmin services will notify your API client using webhooks. There are no API methods that allow your app to query data without first receiving a notification. Sometimes these notifications will contain the new data, and other times these notifications will contain a URL where the new data can be read from. This means that you need to have an API client that is always running and always available to receive these notifications. Depending on your preferred architecture, your API client could consist of dedicated servers, or you could use serverless technologies. The choice is yours. The APIs are indifferent to the technology stack that you choose for your implementation. If you can make and receive HTTP requests and work with JSON, then you should have what you need. You are also going to need a user-facing app. This is where users will authorize your application to have access to their data. At some point in the authorization workflow, your app will need to direct the user to a web view so they can authenticate their Garmin account and authorize access. So there is no avoiding building a front-end application as part of your implementation. Your front-end can be a web, mobile, or desktop app, just as long as you can navigate the user to a web view for authorization. How do you get access to the APIs? First off, access to the developer program is free to approved business partners. At this time, access to the APIs is not available for personal use. To request access to the developer program, you will need to fill out the application located at developer.garmin.com. On the main page, there is a link to the Garmin Connect Developer Program, and then look for the Request Now button. The application asks you to provide information about your company, your project, and how you intend to use the APIs. Also, if you are a contractor working on behalf of another company, you will need to provide information about the company that you are doing the work for. Likewise, if you are outsourcing the work to a subcontractor, then there is a place on the form to enter in the subcontractor's information. We want to know if the integration is being done by a contractor, since more than likely it will be the contractor who will be working directly with our support team during the integration, and we want to make sure that they are who they say they are and that they are actually doing work on your behalf. After filling out the application, you will receive an automated email that your application has been received and is being processed. In most cases, you will hear back within 2 business days if your application has been approved or not. When your application to access the APIs has been approved, you will receive an email with a link to the Garmin Developer Portal. You will also receive an email from a member of the API support team offering to set up an onboarding call where a team member can answer any initial questions that you may have. I recommend taking advantage of this onboarding call as it will allow you to start building a relationship with a member of the support team. It's always good to be able to put a face to a name or a face to an email address. In your approval email will be a link to the developer portal. The developer portal is your jumping off point for working with the APIs. The first time you log into the portal, you will need to use the Forgot Password option to set your password. Once you're logged into the developer portal, you can access the documentation, request API keys by creating your first app, and add other developers to your company's account. The developer portal is where you can access the documentation for the APIs. Each API has its own documentation in the form of a PDF. There's also a Getting Started guide and a separate document for the OAuth process. I recommend downloading the Getting Started guide, the OAuth specification, and the documentation for each API that you will be using. These documents will be your reference guides while integrating with the APIs. Within the developer portal, you can add additional developers to your company's account. If there are multiple developers working on your project, you will want to add them to your company's account. This will give the developers on your team access to the documentation, blog, forums, and your consumer keys. If you're a contractor doing work for multiple companies, you should only need one Garmin developer account. If you use the same email address when being invited to a new team, then you will be able to access all of the teams that you are a member of using a single login. The developer program has its own dedicated developer blog and forums that you can access from the developer portal. The blog is the main communication channel that the API support team at Garmin will use to send out information regarding updates and changes to the APIs. The forum is a good place to ask questions and have them answered by members of the API support team and by other developers using the API who may have experience in the areas that you have questions about. In the developer portal, under your user profile are options to be notified when new content is added to the blog or forum. It's a good idea to enable these notifications so that you do not miss any important announcements. And as always, if you have a question that you do not want to post to the forum, then you can contact the API support team directly by email. In order to begin working with the APIs, you need a consumer key and secret, and to get a consumer key and secret, you will need to create an app. Apps are created in the developer portal and contain the metadata associated with your app, such as the name and branding of your app that will be displayed to users when they authorize your app to access their Garmin account. To create an app, you will need to fill out the application in the developer portal and submit it for approval. Apps are typically approved in 1 to 2 days. Your company has already been approved to use the APIs, and the approval process for the app is mainly to double-check that you are requesting access to the appropriate APIs and to determine if you need an evaluation key or a production key. We'll talk more about evaluation and production apps on the next slide. When creating an app, you should be ready to provide the following information: the user-facing name of your application, the callback URL for the OAuth process. This can be changed later on, so don't worry if you're not sure what that is just yet. You will also need to provide a branding image that will be shown to users during the authorization process. This image needs to be hosted and fetchable over HTTPS, and the image should be no larger than 150 by 150 pixels. We'll see an example of how this image is used in just a few slides. You will also need a link to your company's privacy policy, and you'll need to know the list of APIs that your project requires. After filling out the form and submitting the application, you will receive an email letting you know that your request has been received and is in process. Once your request has been reviewed, you will receive a second email saying that your app has been approved and that you can retrieve your API keys by logging into the developer portal. The first app that you create through the developer portal will be an evaluation app. Evaluation apps and production apps both have access to the Garmin Connect production servers, but evaluation apps are meant to be used during your initial development and testing. Evaluation apps have low rate limits, and evaluation apps also have narrower date range limits for backfilling historical data. We'll talk more about backfilling data later on in the presentation. The only users that should authorize using eval keys are the developers working on the project. It is important that you do not let your end users authorize using an eval key, as they will need to re-auth again when you switch over to using production keys. Once you have completed your initial development and testing, you can request a production key in secret. Before requesting production access, you will need to perform a self-evaluation check for your integration using the Partner Verification tool. The verification tool will perform a series of integration tests and checks. The verification tool will report any errors that it finds, and if there are errors, then you will need to resolve the errors and rerun the verification tool. Each API has its own requirements for validating the integration, and you will need to refer to the documentation for each API that you are using to see what the individual requirements are for each API. Your app will need to meet the requirements of all of the APIs being used before you can create a production app. A common requirement for all APIs is that each endpoint that you have configured needs to have been called in the last 24 hours. We'll be discussing endpoints in more detail shortly. Also, your integration must have queried or received data from at least 2 different Garmin Connect accounts in the last 24 hours, and the data received must have come from a physical Garmin device. Manually entering data in Garmin Connect is not sufficient to pass the verification tests. To pass the tests, your integration should not have returned any errors in the past 24 hours. Your integration should properly handle any quota violations, and your app needs to follow Garmin's brand guidelines when using any Garmin logos or device images. Again, refer to the documentation for each API that you are using for additional requirements. Once all the verification requirements have been met, you can request a production key by creating a new app in the developer portal and requesting a production key. The process is the same as when you created your evaluation app. Since the verification process only requires data from 2 distinct users, it's best to wait until you have created a production app in the portal before beta testing your integration with your end users. It is important that you secure your consumer key in secret so they are not discoverable to anyone outside of your organization. If someone gets a hold of your consumer key in secret, they can impersonate your app and potentially gain access to user data, which we want to avoid. So how do you secure your consumer key in secret? First and foremost, do not use your consumer key in secret in client-side code. The source code for any client app can be decompiled or at a minimum inspected. In obfuscated JavaScript code, a consumer key and secret are still easily found. Android apps can be decompiled, and you can even grep compiled iOS apps and find hard-coded strings. Even easier than decompiling binary code is intercepting HTTP traffic coming from mobile apps and desktop apps. This can be done by the user of your app or by anyone listening on a public network. So it's pretty much impossible to secure your consumer key and secret in client-side code. This is why all communication between your API client and the APIs should be done server to server. As a rule, if you are using your consumer key or secret, then that code should be executed from your server-side code. It is also a best practice not to store your consumer key and secret in a version control system like Git or Bitbucket. Most platforms have secret managers or key vaults, and there are third-party solutions and workflows that can help manage credentials as well. Another benefit of using a secrets manager is that it can help you keep track of multiple evaluation and production keys that you may be using in your application. On the next few slides, we are going to cover onboarding users to your app. We'll talk about the authorization workflow, and then cover the first few things that you want to do after a user completes the authorization process. You will also need to give your users a way to disconnect to their Garmin account from your app, which we will cover as well. A few slides back, we talked about securing your consumer key and secret and mentioned that all communication between your app and the Garmin APIs should be server to server. But how does this impact the authorization workflow? We know that the end user needs to authorize access to their data in a web browser on the client. So what parts of the auth process happen server-side and what parts happen client-side? The 3 steps listed on this slide and the image on this slide are straight from the Garmin Connect OAuth specification document available in the developer portal. We could dedicate an entire presentation, or book actually, to OAuth, but the parts that we want to focus on this slide are the steps that use your consumer key and secret, since that will tell us which steps need to happen server-side. As mentioned a few slides ago, if a step requires that you use your consumer key or secret, then that step should be performed server-side. Keep in mind, this is not something specific to Garmin APIs, rather this is a best practice for any API client implementation. A few other things to quickly mention about implementing an OAuth workflow are: first, use an OAuth library server-side. Regardless of the server-side development stack that you are using, there is a library available that will do the heavy lifting for you. This will speed up your development and keep the number of bugs and headaches to a minimum. On the client side, you just need a browser. For web apps, you're basically navigating the user to a URL, so there's really no need for a library of any sorts. For mobile apps, make sure to follow the guidelines for embedding a web view in your app. Some platforms allow you to embed a web view in your app, while others do not. So it's good to be aware of these guidelines ahead of time, since you do not want to have your app rejected because of this and end up having to rush through a bunch of rework at the last minute. That is a lot of information on one slide, and we're not going to spend much more time talking about OAuth. My best advice to get started with your implementation is to find an OAuth library for your development stack, then plug in your consumer key and secret into the example code and test it out. That should get you pointed in the right direction. Implementing an OAuth workflow is easier said than done, so if this is your first time doing so, then you may want to budget a few extra days in your schedule to work through the details. On the last slide, we talked a bit about what happens behind the scenes when a user authorizes your app to access their Garmin data. So now let's walk through the steps that the user sees. During the auth process, the end user's interactions will all be from within a browser and on web pages that are being served from Garmin.com. It is here that the users will log into their Garmin Connect account and authorize your application to interact with their account. One of the tenets of OAuth is that the client app never sees the user's credentials. And this is enacted by having the user enter their username and password on the host site. Notice in these screenshots the use of the image that was provided when creating the app. This extra branding lets the users know who they are allowing to access their data, so make sure to use an image that aligns with your company's brand. So how does this process even begin? First off, the user can only enter this workflow from inside your app. This process cannot be started from Garmin Connect. Typically in your app, under Settings, there is a Connect with Garmin button that triggers this workflow. Once in this workflow, the first thing the user may see will be a login page on Garmin Connect. Next up is for the user to decide what access they are willing to give your app. When you created your app in the developer portal, you selected the APIs that your app needs access to. But the user is ultimately in control of what data they are willing to allow your app to access. I like to call this the toggles page, since the user can toggle on and off what data they are willing to give your app access to. The last step is for the user to authorize your app to access their data. This is the last step the user participates in during authorization. When the user presses the Authorize button, the OAuth confirm page will respond with an HTTP 307, which is code word for temporary redirect, and include a redirect URL. The browser will then automatically redirect the user to that URL, landing them back in your app. Keep in mind that there is still a final step that the user never sees. This is the server-to-server step where you exchange the authorized request token for a user access token. This step should be triggered from your redirect URI page and occur server-side. Now that you have successfully taken an end user through the authorization process, you are getting closer to working with the APIs. But first, there is some bookkeeping that needs to be taken care of. One of the first things that you will want to do after a user completes the authorization workflow is get their Garmin ID. Each Garmin Connect user has a unique API ID associated with their account. This ID is unique to the API and not the user's actual Garmin user ID, and this ID cannot be used to find out any personal identifying information about the user. So why would you want to retrieve and store this ID? The main reason is that if a user disconnects and reconnects their accounts, the user's access token will change, but their Garmin ID will stay the same. Getting a user's Garmin ID can help you identify if the user is connecting their account to your app for the first time, which may help you determine if you need to perform any one-time initialization tasks like backfilling data. A good place to get the user's Garmin ID is at the end of the authorization workflow, right after acquiring the user access token. You can find the documentation for the user ID endpoint in the Getting Started documentation, which is available in the developer portal. The next thing that you will want to do right after the user completes the authorization workflow is to find out what APIs they granted your app access to. This happened on the toggle screen that the user sees during the authorization workflow. Your app might be requesting access to both the Training API and the Courses API, but the user may have only given your app permission to use one or the other. If you make an API call and the user did not grant your app permission to use that API, the API will respond with the error code HTTP 412 preconditioned failed. Knowing what permissions the user granted your app access to and using that information in your application logic will prevent your app from making API calls that will result in an error. And if you are still using an evaluation key, these errors will prevent the verification tests from succeeding and keep you from getting a production key. In the example shown on the slide, the demo app is requesting access to all of the available APIs, and the user granted access to all of them. Just like getting the user's Garmin ID, a good place to get the user permissions is at the end of the authorization workflow, right after acquiring the user access token. You will also find the documentation for the user permissions endpoint in the Getting Started document available in the developer portal. The last bit of housekeeping that you need to do is to give your user a way to disconnect their Garmin account from your app. This too should be initiated from somewhere in your app that is easy for the user to find. In most cases, the Connect with Garmin button becomes a Disconnect from Garmin button, and vice versa. Disconnecting a user's Garmin account from your app is done by calling the registration endpoint. There are no parameters to this endpoint. Rather, all that is required is to make a signed request with a valid user access token to the registration endpoint with the HTTP verb set to delete. Upon deleting a user access token, all notifications for that user will immediately stop, and any attempts to request data with the user access token will be rejected as unauthorized. The deleted user access token cannot be restored, and the user will need to go through the Auth workflow to reconnect their accounts. Your app should also call the registration endpoint if the user deletes their account on your platform. This will prevent the API from continuing to send your app data for that user. The documentation for the registration endpoint can be found in the Getting Started documentation available in the developer portal. Now let's look at these three API methods in action. For that, I'm going to be using an application called Postman, which is an application that can be used for API testing. The reason that I like using Postman when working with the developer program APIs is that Postman will sign the requests with the correct OAuth headers for us. We tell Postman what our consumer key and secret is, as well as the user access token and secret for the user whose account we would like to interact with, and Postman takes care of the rest, leaving us to focus on the input parameters and responses of the API calls we are testing. For these three API methods, there are no input parameters or request body. Rather, the user access token that is used to sign the request lets the API know whose account we will be making requests for. First, we'll look at the getUserID method. Again, there are no input parameters, just the user access token that is used to sign the request. When we send the request, the API returns the user ID in the body as a JSON object with a single parameter. Next is the user permissions method. When we send the request, the API returns the permissions that the user authorized. These would be the toggles that we spoke about a few slides back, and it looks like this user authorized access to all 5 APIs. And finally is the deregistration method. Once again, there are no input parameters, just the user access token that is used to sign the request. And with this method, nothing is expected to be returned in the body of the response either. Instead, we look for the response code to be an HTTP 204, which means no content. With our chores behind us, we can start working with the APIs. And the place that you'll start doing that is in the API Tools portal. Back in the developer portal is a link to the API Tools, but you can also bookmark it for quicker access. The API Tools is where you will configure and test your endpoints. The API Tools is also where you will access and run the partner verification tool before creating a production app. To log into the API Tools portal, you will need your consumer key and secret. Endpoints are how the Garmin services communicate with your app. Endpoints are implemented in your backend API client and should be configured to accept incoming HTTP post requests. In the API Tools under the Endpoint Configuration section is where you provide the Garmin services the URLs for sending data to your app. There are 2 ways the data can be sent to your app. With ping notifications, your app will receive a URL that it can use to fetch the data. The ping includes both the Garmin ID and the user access token, so you can identify the user that the data belongs to. Getting the data is done by making a signed HTTP request to the provided URL. The data is then returned in the body of the response as JSON. With push notifications, the new data is provided directly in the body of the HTTP post request that is sent to your endpoint. You have the option of using either ping or push for any endpoint. You can even use ping for some endpoints and push for others. But ping notifications are more of a legacy feature of the APIs, and if you are developing a new app, then in most cases you will want to use push notifications and skip having to fetch the data by making a separate HTTP request. One exception to this is the activity files endpoint, which is ping only. The reason why the activity files endpoint is ping only is because of the file size. Activity files may be a few megabytes in size, whereas the corresponding ping may only be a few thousand bytes. The ping lets your app know that a new activity file is available, and your app can fetch the file when it's ready to process it. This is a better use of resources for both the Garmin services and your app. Also make sure that your endpoints use HTTPS. The Endpoint Configuration tool will give you an error and will not let you save your changes if you enter an endpoint URL using HTTP. Another API tool is the Data Generator. The Data Generator can be used to simulate a user syncing data from their device. This provides a quick way to test summary data endpoints without needing to generate the data on an actual Garmin device. The data generator creates semi-random data, and then ping or push notifications are sent to your endpoints for testing. The data generator is useful during development when you do not have access to a device, but you're still interested in the data that that device produces. A good example is if you enable the body composition endpoint, but you do not have a Garmin index scale for testing. The data generator can simulate data from an index scale without having to physically step on a scale. The data generator requires a valid user access token, so you will need to have gone through the authorization workflow before using the data generator. Two other API tools that you will find yourself using are the Backfill and Summary Resender tools. The Backfill and Summary Resender tools are similar to the data generator, but they use real data instead of semi-random data. The Backfill and Summary Resender tools can be used to trigger a resend of all notifications for the provided user access token for the chosen data type and date range. And just like the data generator, using the Backfill and Summary Resender tools requires a valid user access token, so you will need to have gone through the authorization workflow at some point. There's also the option to trigger a backfill programmatically, which you can do in your authorization and onboarding workflows. We'll talk more about backfilling programmatically later in the presentation. And the last API tool that we're going to talk about today is the User Authorization tool. The User Authorization tool can be used to simulate the authorization workflow. You start out by entering your consumer key, and then the tool walks you through each step of the workflow. You'll even be redirected to the Auth Confirm page, where you will log in and authorize access to your account. At the end of the workflow, you will be provided with a valid user access token and user access secret that you can use with the data generator or the backfill and summary resender tools. These IDs will only be shown to you once, so if you plan to use them, you will want to copy and paste them to somewhere secure so that you do not lose them. This tool is meant for developers to quickly get a user access token and secret for testing purposes, and not something that can be used to authorize actual end users. Where this tool comes in handy is for getting a user access token before you have completed the authorization workflow for your app. Regardless of the APIs that you are using, there are two required endpoints that you must implement in order to get production credentials. These are the deauthorize endpoint and the user permissions changed endpoint. Technically, the user permissions changed endpoint is not a required endpoint. Rather, it is a best practice that you should implement this endpoint. So what are these endpoints used for? Earlier, we spoke about the delete user access token and get user permission API methods that allow your app to delete a user access token or query the state of the toggles to know what APIs a user has given your app access to. And you should be using both of those methods when a user triggers an action from within your app. But users can also disconnect their account from your app from within Garmin Connect, and users can also change the state of the toggles at any time from within Garmin Connect. And these two endpoints enable your app to be notified when the user takes either of these actions. The deregistration endpoint is triggered when a user disconnects their Garmin account from your application. This is to let you know that this action has occurred. Knowing that a user disconnected their Garmin account from your app will allow your app to react appropriately. When a user disconnects their Garmin account from your app, you will want to delete the access token and secret associated with the user's account from your database. And you will want your app to present the user with the option to connect with Garmin. The deregistration endpoint is push only and will contain an array of deregistration objects that contain the Garmin ID and user access token of the users who just disconnected their accounts. Knowing that a user toggled off access to an API can prevent your app from making any calls to that API that would result in an error. This is especially useful with the Training API and the Courses API, where your app is writing data to Garmin Connect, and doing so after the user revoked access to either of these APIs would result in an HTTP 412 preconditioned failed error. Being notified that a user toggled off the activity or health APIs can also be useful for knowing why your app is no longer receiving data for that user. If a user writes into your support team saying that their Garmin data is not showing up in your app, it would be good to know if the user disabled that API. This can save a lot of back and forth with that user if you can give them a definitive reason as to why their data is no longer syncing and let them know what they need to do to fix it. Likewise, if the user toggles access back on, your app can expect to receive data from those APIs again. Or in the case of the Training and Courses API, your app can start pushing data to the user's Garmin Connect account once again. Time for another demo. Once again, we will be working with user permissions and deregistrations, but this time, rather than our app querying the API for user permissions or our app triggering the deregistration, we'll be watching the Garmin services send push notifications to our endpoints. And for that, we're going to need a simple server. On the left side of the screen is a simple Node.js server that prints out the URL of the incoming request, and then prints out a formatted version of the request body. The server then immediately returns an HTTP 200 response to the caller. This is a very simple API client, and I anticipate that your client will be much more robust. Then, on the right side of the screen is the account settings page in Garmin Connect. Here we can see the toggles once again and a disconnect button. Let's see what happens when we change the state of the toggles. First, I will just change one toggle, which will trigger a single push notification to be sent to our endpoint. There it is, and we can see our simple server printing the payload to the debug console. As expected, we get a user ID and user access token, either of which can be used to pair this request with a user in your app, and we can see a list of APIs that our app now has access to for this user. Let's clear the debug console and trigger another push notification. This time, I'm going to quickly change the state of a couple of the toggles. What I'm hoping to show is a single push notification to our endpoint that contains data from more than one event. And it looks like that happened. Scrolling through the response, we can see that a single push notification was sent to our endpoint that contains data for multiple events. Let's clear the debug console one more time. Finally, I'm going to hit the disconnect button and we can see the deregistration notification come in. In your app, this would be your cue to perform the necessary cleanup task to mark this user has disconnected from Garmin Connect. And we can see that the push notification came in, this time giving us just the user ID and user access token so we know which user to mark as disconnected. For the demo on the previous slide, the Express server was running locally on my laptop. There was even a debugger attached, and I could have set breakpoints and stepped through the code as the endpoints were being executed. On the next few slides, we'll talk about how I set this up and talk about other options for debugging your endpoints locally. For the endpoint demo a few slides back, how was it possible for the Garmin services to reach the endpoints running on my local development server? The way it worked was that, running in the background was an app called ngrok, and please let me know in the comments if I'm pronouncing that incorrectly. ngrok is a tunneling software that allows you to expose a web server running on your local machine to the internet. When you start ngrok, you will get the public URL of your tunnel. You will then use that URL to configure the endpoints back in the API tools. Keep in mind that once you shut down the ngrok process, these URLs will no longer be valid, so make sure to update the endpoints in the API tools when you are finished debugging. You'll want to either disable these endpoints or point them back to your actual services. Local Tunnel is another application that does the same thing as ngrok. There are others, but these are the two that I have used in the past. Another way to debug your endpoints locally is with an API client that allows you to mock HTTP requests that mimic how the Garmin services will call your endpoints. Postman and curl are probably the most popular of these tools, but there are others. Using an API client, you can simulate payloads and quickly test different scenarios. Postman is a desktop app, where curl is a command line app. We saw an example of using Postman earlier when we retrieved the authorized user's Garmin ID and permissions. I've mentioned a few times that it's possible to receive data from multiple users in the payload of a single ping or push, but it's hard to predict when that may happen, and a good option to test this scenario may be to mock it instead. This is where an API client like Postman or curl can be useful. For this demo, we'll be using Postman to send mock calls to our endpoints. On the left side of the screen is the same bare-bones Node.js app that we saw earlier. On the right side of the screen is the Postman app configured to post data to our user permission change endpoint. In Postman, we have a mock payload that contains the data for two different users. And by that, I mean that the payload contains an array of user permission change actions, and each item in the array has a different user access token and user ID. When we send the data from Postman to our endpoint, you can see that the data is received by our app and is printed out. But if this was a real app, we would iterate over each item in the array and treat it as a separate event. Using Postman for this purpose is not unique to working with the developer program APIs, but what is unique is the payloads that are being simulated. Plus, using an API client is an easy way to simulate different scenarios without having to wait for those scenarios to occur in the wild. Earlier, we talked about the web-based tools for backfilling historical data, but backfills can also be triggered programmatically. When a user connects their Garmin account to your application will start receiving notifications for any new data that the user generates. But what if your application needs 3 weeks of data in order to provide the user with a complete experience? Instead of waiting for 3 weeks, you could immediately request a backfill of the last 3 weeks of the user's data. Having this data would then let you communicate your app's value prop to your user within minutes and not weeks. For the Health API, you will be able to request up to 2 years of past data for each user. And for the Activity API, you will be able to request up to 5 years of past data for each user. Each endpoint has a corresponding backfill API method, which is described in the API documentation. The historical data will be sent to the same endpoints as new data, and you will need to have the corresponding endpoint enabled to receive the historical data. Something to be aware of when requesting historical data is, if you make multiple requests for the same date range for a given user access token, you will get back an HTTP 409 response. For testing, since the limits are tied to a user access token, you can disconnect your account and reconnect, and then make a second request for that date range. This may be something that you find yourself doing quite often during development, but this is not really a workflow that you want to ask your end users to do. So make sure to thoroughly test your backfill process before releasing it to your end users. When data is delivered to one of your endpoints, be it a push or a ping, the payload may contain data for multiple users, or the payload may contain multiple pieces of data for a single user. This is most often the case when performing a backfill. This is something that you may or may not see in your initial development when you only have a few users testing your application, but is something that you should anticipate. If you do not encounter this scenario during your initial development, you can use a tool like Postman to call your endpoints to mock this behavior. One of the reasons that you need to properly handle a payload that contains large amounts of data is that your client only has 30 seconds to respond with an HTTP OK before the operation is marked as a failure. In the case of a failed ping or push notification, the API will resend the data on a regular basis until an HTTP OK is returned. The retries will be spaced out farther and farther, and eventually the API will stop resending the notifications altogether. But in the meantime, your client could be processing duplicate notifications for data that it has already received. The way to avoid this is to not perform any long-running operations in your endpoints. What you need to do instead is either cache or queue the incoming payloads, respond to the notification with an HTTP OK, and process the data asynchronously. Up to this point, we have been talking mostly about things that are common to all of the APIs. So now let's talk about some of the specifics of each API. The Activity API provides access to the detailed fitness data captured during an activity on the user's wearable device or cycling computer. Summary data, such as overall distance and duration, sport type, pace, heart rate, and much more is available to your application as JSON by implementing the activities endpoint. This data can be pushed directly to your endpoint as JSON, or you may choose to get a ping notification and then fetch the data using the provided URL. The payload is relatively small, and you may find it more efficient to have the JSON pushed directly to your endpoints. If you need more detailed information about the activity, such as the GPS track, lap summaries, or the second-by-second heart rate, speed, cadence, or power data, then you will want to use the activity files endpoint to get the original file recorded by the device. The three file types that you can expect to receive are TCX, GPX, and FIT. TCX and GPX are XML-based file formats, whereas FIT is a binary format used by Garmin devices to record activity data. FIT will be the format that you will encounter most often. The activity files are available by ping notification only, and you will need to use the provided URL to download the file. If you implement the activity files endpoint, then you will need to be able to decode the binary FIT files that you receive. To do this, you will want to use the FIT SDK. The FIT SDK is available at developer.garmin.com/fit and is available for the C, C++, C#, and Java programming languages. The FIT SDK site includes how-to articles and example code for working with FIT files, which should help you get started. There is also a public forum for the FIT SDK where you can ask questions. Also included in the FIT SDK is the FIT CSV tool. The FIT CSV tool is a command-line tool that can be used to convert binary files to readable text files. These text files can be viewed in a text editor or spreadsheet application. Converting FIT files to text files may help you with your debugging. If your application is not able to process a FIT file, the text version of the file may help you understand what is going wrong by being able to see inside of the file. For the next demo, we will be exercising the Activity API Endpoints. On the left side of the screen is the same Node.js app that we have been using throughout the presentation. Once again, I'm using ngrok to tunnel requests from the Garmin services to my API client. Back in the API Tools portal, I have already configured the Activities endpoint for push notifications, as well as the Activity Files endpoint for ping notifications. Now all we need is for one of our users to upload data to their account. For that, I'm going to manually upload a FIT activity file to Garmin Connect, which will trigger notifications to be sent to the endpoints. As far as these endpoints go, it does not matter if the activity file was synced from a device or manually uploaded. And manually uploading files is a quick way to test and debug your endpoints. In the debug console, we can see a printout of the summary data that was pushed to the activities endpoint, and somewhere in here is the ping to the activities file endpoint with the URL that can be used to download the file. Let's grab that URL and head over to Postman to download the file. You can tell that this is a FIT file because we can see the string .fit in the header. We can save the response. Let's call it run.fit, which should be an identical copy to the file that we manually uploaded a few steps back. There's one more use case of the Activity API and FIT files that I want to talk about before moving on to the Training API. We have been talking about how the Activity API can be used to get the FIT file recorded by the device. So now let's say that you are developing a new sports sensor that you want to integrate into the Garmin ecosystem, and you also want to get the data from that sensor back into your ecosystem. One way to do this could be to use a ConnectIQ app or data field to connect your ANT or BLE sensor to a Garmin device and display data in real time on the device. Next, have your ConnectIQ app add the data from your sensor to the FIT file as it's being recorded by the device. That same FIT file with the same data from your ConnectIQ app could then be delivered to your platform using the Activity API. And finally, using the FIT SDK, you could read your custom data from the file for use in your platform. A few places that I've seen this implemented successfully have been with running power sensors, muscle oxygen sensors, and core temperature sensors. The Training API allows you to send workouts and training plans from your platform to a user's Garmin Connect account. The training API is divided into two sets of functionality. The first is for creating workouts in a user's Garmin Connect account, and the second is for scheduling those workouts on the user's Garmin Connect calendar. If a workout is scheduled on a user's Garmin Connect calendar, then that workout will be automatically sent to any of that user's supported devices. For instance, cycling workouts will sync to both cycling computers and multi-sport wearables, and running workouts will sync to both running and multi-sport wearables. But running workouts will not be synced to a cycling computer. The logic follows the functionality of the device. If the device supports the sport type, then the workout will be sent to that device. Once the scheduled workout is synced to the user's device, the device will prompt the user to perform the workout on the scheduled date. Right now, scheduling is by date only. You cannot specify a time of day or order in which to perform the workouts. So if you're scheduling multiple workouts on a single day, it will be up to the user to decide which order that they perform them in. Something else to know is, if you're only adding workouts to the library, then the user will need to use the Send to Device option in the workout list to sync that workout to their device. Users can also schedule workouts from the library on their calendar, and those workouts will be automatically sent to the device the next time the device syncs with Connect. As you work with the training API, keep in mind that it's always a two-step process to get the workout down to the user's device. The first step is always going to be adding the workout to the user's workout library, and the second step is scheduling the workout manually or with the API, or the user manually choosing to send the workouts to their device. Now let's see a demo of the training API in action. Once again, I'm going to be using Postman for the API client, and you can see that I have already set up the API calls for both the workout methods and the scheduling methods. This time, on the right side of the screen is Garmin Connect. And we can see that in this account, there are no scheduled workouts on the calendar. And there are no workouts in the library. So let's change that. First things first, I'm going to be using the training API to create a workout. The create workout method responds with the workout ID for the newly created workout, which we will need when reading, updating, or deleting this workout. So this is a value that you will want to store. For the demo, I'm storing the workout ID in a variable so I can use it later on. Using this workout ID, we can retrieve the workout, we can update the workout, and later on, we'll use it to delete the workout. Now that we have created the workout, let's refresh Garmin Connect and make sure that the workout is in the library. And it looks like it is. With the workout in the library, we can now schedule the workout on the user's calendar. Back in Postman, we will call the schedule workout endpoint with both the workout ID and the date that we would like to schedule the workout on. Just like the workout ID, I'm storing the schedule ID in a variable so that I can use it later on. Let's check the calendar in Garmin Connect to verify that the workout was scheduled. And it looks like it was, since we can see the workout on this user's calendar. The training API also allows you to read a schedule back using a schedule ID, or by using a date range. These methods will only return the workouts scheduled by your app. Now let's reverse these steps and unschedule the workout and then remove the workout from the library. Refreshing Garmin Connect. We can see that the workout is no longer on the calendar. After deleting the workout, we can also see that the workout is no longer in the library. The Courses API allows you to create, read, update, and delete courses in a user's Garmin Connect account, and the changes will be automatically sent to the user's device the next time the device syncs with Garmin Connect. The same thing applies to the Courses API as the Training API, where courses will only be sent to a device that supports courses. If a device does not support courses, then no courses will be sent to that device. The Health API gives you access to wellness information tracked by Garmin wearable devices. With the Health API, you have access to data like steps, floors climbed, and active minutes. You also have access to body composition data, sleep data, including sleep stage classifications, and all-day metrics like heart rate, stress, body battery, respiration rate, and pulse ox. Additionally, the Women's Health API provides access to menstrual cycle tracking. An important thing to keep in mind when using these APIs is that not every Garmin wearable supports every one of these features, or a user may not take advantage of every feature. So what you want to avoid is only testing your app using the latest and greatest device with all of the features enabled. Because as you add users, what you may find is that you may not receive the same data for every user, which is something that you should anticipate from the beginning. If you've done any work with date time values and time zones, then you know it is always a little bit harder than you think it should be. So to make working with dates and time zones a little bit easier, many of the APIs return 3 date-time related values. The first is the start time in seconds since the Unix epoch, which is the number of seconds that have elapsed since midnight on January 1st, 1970 UTC. The second is the start time offset in seconds value, which is the number of seconds to add to the start time value to get the local date time of the data. Keep in mind that this value may be negative, so if you plan on storing this value, make sure to use a signed integer. Also keep in mind that if your users are traveling, then they may change time zones, so don't assume that your users are always in the same time zone. Then the third value that is returned for summary endpoints is calendar date, which is the date that this data is displayed on the user's Garmin Connect calendar. This value is already in the user's local time and does not need any further manipulation. Calendar date works great for all day type metrics like steps, where you do not necessarily assign a time of day to the value. Whereas start time and start time offset are something that you'd use to figure out when someone woke up in the morning. Between these 3 values and some patience, you should have what you need to display the correct date time to your users. If you have a question while working with any of the APIs, you can check out the blog to see if there are any posts that answer your question. If you do not find what you are looking for in the blog, then search the forum to see if your question has already been asked and hopefully answered. If not, you can post a new question to the forum. And as always, you can reach out to the API support team directly by email.